Hello friends, in today's class we'll try to find answers to the questions of exercises of chapter 13. The topic is on light. So I made one video on this topic, and in that video I have covered questions number 1 to 4. So if you have not seen that video, you see that video first, so you will understand the concept of light and the laws of reflection, and then you can follow this video and see how we answer the questions number 5 onwards. So let's read the question 5. You please take out your books and read that question. Describe an activity to show that the incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. So in my last video, I told you there are two laws of reflection. First law is that angle of incidence and angle of reflection are always equal. And second law is that the incident ray, reflected ray, and the normal are on the same plane. So for example, now if we assume that this is a mirror, this is a mirror, and we place a sheet of paper near the mirror, and we draw a line which is at right angle to the mirror. This line is at right angle to the mirror. For example, this is the mirror and this is the sheet of paper, and there is a line, and this line makes an angle of 90 degree with the mirror. It is called normal. Why is it called normal? Because it is at 90 degree to the surface of the mirror. Okay? Now what do? We take out a torch to throw a beam of light, and we'll throw a beam of light through a hole. We'll adjust this in such a way that the beam of light will touch this point. The beam of light will touch this point. This is your torch. And there is a cardboard with a pinhole. Through that pinhole, we'll throw a beam of light, and this beam of light should touch the point where the normal has been drawn. And it should be adjusted in such a way that you can see the beam on the paper. You should be able to see the beam on the paper. How can you do it? You have to just adjust your torch and the pinhole. And then you will see the reflected beam here. It will be seen on the paper like this way. For example, if this is the incident ray, this will be the reflected ray. And they will be all on the same paper. That means they will be all on one plane. This incident ray, the normal, and the reflected ray. How can you check it? If you, for example, tilt this paper from this side, if you tilt it from this side, you will not be able to see it on the paper. Maybe you will see it only partly. Up to the portion, it is still plain. We are partly bending it, not fully bending it. So the part which is not bent, which is on a plane with the incident ray, you will be able to see it. But you will not be able to see it on the bent portion. So this way you can prove that the incident ray, the normal, and the reflected ray, this is the reflected ray. Reflected ray. It bounces back from the mirror. This is the incident ray. Incident ray. This ray bounces back from the mirror and goes in this direction. And it goes in such a way that this angle is equal to this angle. Angle I is equal to angle R. And they are on the same plane. This can be verified by adjusting the sheet of paper. If you push it up or push it down, you will not be able to see the beam of light, the reflected beam of light. Okay, this way you can physically establish the fact that incident ray, normal, and reflected are on the same plane. As long as the sheet will be plane, you can see all two beams. And the normal is already there drawn by a pencil. So that is your question number 5. Now let's come to question number 6. Here you have to fill some blanks. So I'll explain the concept behind each point. You read the points and see what blank has to be filled up. So let's come to question number 6. A person 1 meter in front of a plane mirror seems to be so many meters away from the image. This is a mirror and there is a person standing here. His distance is 1 meter from the mirror. Okay, where will be his image? His image will be 1 meter from the mirror, because the image is as far from the surface of the mirror as is the object in front of it. जितनी दूरी ऑब्जेक्ट की होती है उतनी दूरी इमेज की होती है. तो इसकी दूरी यहां से कितनी होगी? 2 मीटर्स. इसको दिखाई देगा कि इसकी इमेज 2 मीटर दूर है. He will see his image at a distance of 2 meters from his position. मिरर से 1 मीटर दूर है और यहां से 2 मीटर दूर है. तो the answer will be 2 meters. So that is the answer to the first question. Because distance between the image and the mirror and the image and the object is same. तो total distance हो जाएगा 2 meters. That is the answer to the first question, part A. Part B. If you touch your dash ear with the right hand in front of a plane mirror, it will be seen in the mirror that your right ear is touched by the dash hand. Okay, you are touching one of your ears by right hand. राइट हैंड से आप एक कान छू रहे हो, तो आपको इमेज में दिख रहा है कि आप अपना राइट ईयर छू रहे हो. किस हैंड से छू रहे हो वो बताना है. तो ऐसा होगा, इट इज लेटरल इन्वर्शन. इट इज कॉल्ड लेटरल इन्वर्शन. लेटरल इन्वर्शन का मतलब क्या होता है? द राइट साइड ऑफ द ऑब्जेक्ट विल अपीयर on left side of image. और जो लेफ्ट साइड है वो राइट पे दिखाई देगी. दिस इज कॉल्ड लेटरल इन्वर्शन. तो इफ यू सी इन योर इमेज दैट यू आर टचिंग राइट ईयर इन द इमेज, इफ इट इज राइट, तो एक्चुअली यू आर यूजिंग योर लेफ्ट ईयर. सो पहले में आ जाएगा लेफ्ट. Because in the image you see you are touching your right ear. इमेज में राइट है तो ऑब्जेक्ट में लेफ्ट होगा. तो फर्स्ट ब्लैंक में लिखेंगे लेफ्ट. एंड यू आर टचिंग विद राइट हैंड, इमेज में राइट हैंड विल अपीयर लेफ्ट हैंड. तो सेकंड में आप लिखेंगे लेफ्ट हैंड. तो ये 2 ब्लैंक्स हैं. दीज आर द 2 ब्लैंक्स दैट यू हैव टू फिल अप. फर्स्ट ब्लैंक में यू विल से लेफ्ट ईयर and second blank you will say left. दोनों में लेफ्ट है. लेफ्ट ईयर विद राइट हैंड, राइट ईयर विद लेफ्ट हैंड. लेफ्ट पहला ब्लैंक है, सेकंड ब्लैंक इज लेफ्ट हैंड. दिस इज द वे यू फिल अप द 2 blanks. Okay, when you touch your left ear, it will appear you are touching your right ear. And you are using right hand, it will appear you are using your left hand. ठीक है? C. The size of the pupil becomes dash when you see dim light. When we look at the objects, the size of the pupil changes. When the light is bright, the size will become smaller, so that less light enters the eye. If it is dim light, the pupil will become larger, so that you can see more light. More light enters the eye, and you can see the object clearly. It will become large. pupil becomes large. It becomes large so that more light can enter the eye and you can see the object clearly. कई बार ऐसा होता है ना, sometimes you are, let us say, in this room, the light is on. Right now, your pupil has shrunk. It is of a smaller size. Suddenly, light goes off. It will appear pitch dark to you. But after some time, the pupil will become larger and you will be able to see something in dim light that may be present in the room. D. Night birds have less cones with rods in their eyes. इसका आंसर है fewer cones or less cones. Fewer ये लिख सकते हैं, fewer cones. Because cones are that part of the eye which see the dim light, and rods see the bright lights. ठीक है? If you see at this given in the book here, cones and rods. Where is the concept given? It's here somewhere here. I read it. The cones, there are two kinds of cells. The cones are sensitive to bright light and rods are sensitive to dim light. So because the night birds can see in the night, that means they can see in dim light. They can see in dim light because they have more of rods and less of cones. They have more rods. Rods are cells which can see in dim light, which are sensitive to dim light. So they have fewer cones. That means they have more of the rods. So now we come to question number 7. Angle of incidence is equal to angle of reflection. There are 4 options. You have to pick up which option is right. First option is always. Second is sometimes. C, under special conditions. D, normal. So these are the 4 options. Always, sometimes, under special circumstances, special conditions, never. So we already know the law of reflection, the first law. The angle of incidence is always equal to the angle of reflection. So this is the right answer. It is always equal to the angle of reflection. Angle of incidence, sorry. So this is the mirror, this is normal, this is the incident ray, this is the reflected ray. This angle is always equal to this angle. This is I, this is R. I is always equal to R. So let's come to question number 8. Image formed by a plane mirror is, now there are 4 options. What is the nature of the image formed in a plane mirror? So we know the image formed in a plane mirror is virtual. Second, it is erect. For example, when we see our image in the mirror, we ourselves see erect. It is not that we see our feet up and the head down. 3, it is same size. Virtual, erect, same size. And 4th is distance. It is as far from the surface of the image as is the object in front of the It is as far behind the surface of the mirror as is the object in front of the mirror. This is the mirror, this is the object, this is the image, this distance is equal to this distance. Let us say this is x centimeter, this will be x centimeter. So these are the four properties of a virtual image formed in a plane mirror. So you have to pick up the correct option. The correct option is B. Answer is B. Virtual, behind the mirror and same size. It is behind the mirror. We see ourselves inside the mirror. ठीक है? So this is question number 8. Okay? I think it's fairly long video. We'll close it at here, and the remaining questions we'll do in the next video. Okay? If you like my video, please share it with your friends and subscribe my channel. Thank you.